Hello, in this video we're looking at MEI Further Pure 1, the January 2011 paper, question 8, which is on complex numbers. It's a long question, so it's worth reading it through carefully first. We're asked to consider a function with real coefficients, and the equation f of z equals 0 has roots alpha, beta, gamma and delta, and we're told alpha and beta. We're asked to write down the other complex root and explain why the equation must have a second real root. We're asked to write down the value of alpha plus beta plus gamma plus delta and find the second root. For part 3, we're asked to find the values of a, b and c, and by the number of marks, that's where the meat of the question is. And then for part 4, write down f of minus z, and the roots of f of minus z equals 0. It's only 2 marks, so that should be straightforward when we get there. Okay, for part 1, write down the other complex root. Well, we know that complex roots occur in conjugate pairs, so the other complex root is 1 minus j. And we know that in an equation with real coefficients, complex roots occur in conjugate pairs. As the third root is real, the fourth root must also be real. If it wasn't real, we'd need to have a fifth root to be a pair with it, and it's a quartic equation, so we know it only has 4 roots. Okay, write down the value of alpha plus beta plus gamma plus delta, where we know that that is minus the coefficient of z cubed, so that's minus 1, which is 1. And we know alpha, beta and gamma, that's 1 plus j, plus gamma, the one we've just worked out, leaving delta. The plus j and the minus j cancel, so we've got 3 plus delta equals 1, and therefore delta is equal to minus 2. Then we've got to find the values of a, b and c, and there are 2 obvious methods for this. The first one is continuing with the theme from part 2 of looking at the coefficients and the combinations of the roots. So we'll do that method first. We've looked at the sum of the roots, so now we're going to look at the sum of the product pairs. Alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta. And we work those out. Alpha beta is 1 plus j, alpha gamma is 1 minus j, and alpha delta is minus 2. Beta gamma is 1 plus j times 1 minus j. Beta delta is minus 2 minus 2j, and gamma delta is minus 2 plus 2j. So the minus 2j and the plus 2j cancel, the plus j and the minus j cancel, and then at the beginning I've got 1 plus 1 minus 2, so that cancels as well. Then I've got 1 plus j, 1 minus j is 1 minus j squared, minus 4. That's 1 plus 1 minus 4, which is minus 2. And that is equal to the coefficient of z squared, which is a. Now I'm going to look at the roots in triples. So alpha beta gamma plus beta gamma delta plus gamma delta alpha plus delta alpha beta. So alpha is 1, so that's 1 plus j, 1 minus j. minus 2 lots of 1 plus j, 1 minus j. Gamma delta times 1 is minus 2 plus 2j, and then delta times alpha times beta is minus 2 minus 2j. That's 1 minus j squared. And the second one is that multiplied by 2, so minus 2 plus 2j squared. And the plus 2j and the minus 2j cancel, leaving me with minus 4. So 1 minus j squared is 2, minus 2 is nothing. Plus 2j squared is minus 2, minus 4 is minus 6. And that's equal to minus the coefficient of z, which is minus b, and therefore b is equal to 6. Then I can take the product of all the roots, alpha, beta, gamma, delta, which is 1 plus j, 1 minus j, multiplied by minus 2. That's minus 2 plus 2j squared, which is minus 4, and that's the constant term at the end, c. That's part 3, and for part 4 I just have to write down f of minus z. So that's putting minus z in instead of z. Doesn't have any effect on z to the 4. It changes the sign of z cubed. It has no effect on z squared, and a was minus 2, so that's minus 2z squared. It does change the sign of z, so that will be minus 6z, and then c was minus 4. And the roots of f of minus z equals 0. I just minus the roots of f of z equals 0, so that's minus 1 minus 1 minus j, minus 1 plus j, and 2. Let's have a look at the alternative method for part 3. This is using factors from the roots that we've got and then just multiplying it all out to find the function. So the root 1 gives me a factor z minus 1, and the root minus 2 gives me a factor of z plus 2. The root 1 plus j gives me a factor of z minus 1 plus j, and the root 1 minus j gives me a factor of z minus 1 minus j. And I've written it out like that with brackets to make sure that I don't make any mistakes with the minus signs. Multiplying out the first pair, z squared plus z minus 2. And then writing the second pair without the brackets, z minus 1 minus j, z minus 1 plus j. And then multiplying out the second pair, z squared minus z plus jz, minus z plus 1 minus j, minus jz plus j minus j squared. The plus jz cancels with the minus jz, the minus j cancels with the plus j. So that comes out to be z squared plus z minus 2 multiplied by z squared minus 2z plus 1 minus minus 1, so plus 2. Multiplying that out, I get z to the 4 minus 2z cubed plus 2z squared plus z cubed minus 2z squared plus 2z minus 2z squared plus 4z minus 4. And that's z to the power 4 minus 2z cubed plus z cubed is minus z cubed, which we know is correct. So that's encouraging, suggests we haven't made any mistakes. Minus 2zq squared, 2z squared minus 2z squared cancels, minus another 2z squared. And then 2z plus 4z is plus 6z and minus 4. Therefore A is equal to minus 2, B is equal to 6, and C is equal to minus 4. And then part 4 follows as before. Okay, let's have a look at the mark scheme for this question. For part 1, there's just a single mark for writing down 1 minus j and an explanation mark where you must mention that complex roots occur in conjugate pairs. For part 2, there's a single mark for noting that that sum is equal to 1. There's then a method mark for substituting in the roots that you know, and an answer mark, correct answer only, for getting the fourth root. For part 3, there are method marks. Basically 2 method marks for the root relationships attempted. Two marks for evidence of all 3, 1 mark for evidence of 2 being used, or substitution to get 3 equations. For then following through, there's just an answer mark, an accuracy mark for each of the values A, B and C. C you don't need to do any working for, that's just getting that answer, 1 plus j, 1 minus j, multiplied by minus 2. There is for this one a special case follow through from your second real root. For part 4, there is B1 mark follow through, and it must be simplified, and B1 correct answer only for all 4 roots. For the alternative method for part 3, there is a B1 mark, correct factors from your roots. So if you made a mistake with your roots, you can still get that B mark. There's then a method mark for attempting to expand all 4 factors. And then accuracy marks for actually managing to get down to the correct values for A, B and C. If you want to find videos of other questions on this unit or on other units, please visit the Further Mathematics Support Programme's website. Goodbye.